Hello students, today we are going to discuss an important topic from the physics, that is we are going to deal with vectors. Now vectors is a very important concept which we'll be using in physics. So first of all, to start with vectors, one must know what is scalar quantity. Scalar quantity kya hoti hai? So when we talk about scalar quantity, that is going to be basically a quantity which has only magnitude, no direction. So that is your scalar quantity. So when we talk about a scalar quantity, it's a quantity which has only magnitude. Now when we see its definition, or we can say that scalar quantity is defined as a quantity which has only magnitude, and of course it will have a unit. Now when we talk about a magnitude, means like if we talk about distance, so distance is measured in terms of meter, let's say 15 meter, 20 meter. So over there 15, 20, they are basically your magnitude. So if I talk about distance, so distance is an scalar quantity, right? And it has magnitude, let's say 15, and also it has a unit. So unit is going to be meter, centimeter, or millimeter, anything it could be, right? So that's a scalar quantity. Now but when I talk about vector, so vector is basically a quantity that has magnitude and as well as direction. So most important, vector are those which have magnitude and as well as specified direction. So when we talk about vector, we have an example of force. Suppose there is an object and we are applying a force of, let's say, 5 Newton. So this 5 is going to be the magnitude, Newton will be of course unit, and this is the direction. So it's a vector quantity. So distance is just a scalar, but when we talk about force over here, it's an example of vector quantity, right? So anything which has magnitude and as well as direction is going to be your vector. Now we have representation of vector. How we are going to represent a vector, means एक वेक्टर को हम किस तरह से रिप्रेजेंट कर सकते हैं, that we are going to see. So when we talk about a vector, it has basically a tail, that is the starting point of the vector, and we also have a head, that is the ending point. So this is initial point and this is going to be final point, and this will be its direction, that is from tail to head. So starting point in the vector is called as your tail and the ending point is your head. So this is the direction from tail to head, and this is going to be the length. So that will be your magnitude. So we have magnitude and as well as direction. Now when we move further, we have a question based on this. Now let's see the question. What question says, which of the following quantity is a vector quantity? They are asking us which of the quantity is your vector. So if I talk about mass, mass is a scalar quantity, 15 kg, 20 kg, so that's a scalar. Even we talk about power, so power is also a scalar quantity, right? Now when we talk about energy, so energy also has no direction, so again it's a scalar quantity. But importantly, as we have discussed, force. Now what is force? Force is your vector quantity. So which option is going to be the correct one? Option number A. So A is your vector quantity, that is your force. I hope you understood it. Now let's see further. So we have various types of vectors. Now what are those? Let's see one by one. So the first one is your polar vectors. Now what do you mean by polar vectors? Polar vector means having a starting point, like we have seen in the case of displacement. You can see it from the diagram that there is a starting point and you are applying a force. So this is basically your point of application, and let's say this is your vector and it is making an angle of theta with horizontal line. So that's a representation of which quantity? That's a representation of polar vectors. I hope you understood it. Now the next one is your axial vectors. Now vectors, first one we have seen that those were polar. Now we are seeing axial vectors. Now what are axial vectors? Axial vectors basically represents rotational effects and are always along the axis of rotation. Suppose let's say you have this as an axis, and suppose there is a particle P which is at a distance of, let's say, r unit from the axis, and you are applying a force. So basically this particle is going to rotate about this axis. So this will be your axis, right? So the axial vectors are going to be along the axis. Now you have applied a force, and using a right hand thumb rule, you can see that, let's say this is r distance and this is the point of application of force. So thumb indicates your axial vectors. So when we talk about examples of it, we have angular displacement, angular velocity, angular acceleration, and of course torque. So these are the basically representations of those vectors, and these are going to be always along the axis, so they are going to be your axial vectors, right? Now we have another, that is your diagram, which shows that suppose this is an axis and let's say this is the distance and you are applying a force. So over here the axial vector is going to be your torque. I hope you understood it. Now let's move further. So we have a question based on this. Now what does the question says, that why current is not a vector although it appears to possess a direction and of course it has a magnitude as well. So यहाँ पे हमसे पूछ रहे हैं कि करंट एक ऐसी क्वांटिटी जिसका मैग्नीट्यूड भी होता है और डायरेक्शन भी होता है, so it has to be vector, but why it is not a vector? So basically in case of current, see, we have studied the standard definition that anything which has magnitude and as well as direction, it is going to be a vector. But in case of current, when we talk about current, suppose we have a point, let's say that is your junction, and current is coming from to this junction from one side and from the other and going in the third direction. So let's say this is of current 2 ampere and this one is of 3 ampere. So what current will come out of this junction? That is going to be a 5 ampere. So that is basically, you have just done the algebraic sum. So whenever the algebraic sum is feasible, so that's only possible case when it's a scalar. For vector, there are some other rules to add 2 vectors or 2 or more vectors. So those vector rules were not satisfied for the case of current. So that's where the current is going to be your scalar quantity. Now we are going to see some other types of vectors. Let's see one by one what are those. So the first one is zero vector. Now what is zero vector? A vector which has a zero magnitude is going to be your zero vector, right? So that's a vector which has zero magnitude, that will be your zero vector. Now when we see the next one, we have a proper vector. A proper vector is going to be basically a vector having non-zero magnitude. Means suppose हमारे पास कोई एक vector है और जिसका magnitude let's say 3, 4 anything है. So that is going to be your proper vector, right? That means it has a length. Length means it has a magnitude, right? That is, it has a tail and it has a head. So basically that is going to be your proper vector, right? Now we have another term, that is your like vectors. अब like vectors क्या होते हैं? Basically अगर हम बात करें तो like vectors के अंदर suppose we have this one as your first vector and this one as your second vector. So if they are in same direction, now their directions are same irrespective of magnitude. Like एक छोटा एक बड़ा है तो magnitude पे depend नहीं कर रहा है, सिर्फ उसका अगर direction same है, so they are going to be your like vectors. So two vectors are said to be like if they are in same direction irrespective of magnitude. Next one, if we say what is unlike vectors? Now two vectors are said to be unlike if they are in opposite direction irrespective of magnitude. ये हमारा एग्जाम्पल हो गया किसका? अनलाइक वेक्टर्स का. सपोज एक का फोर्स का डायरेक्शन इधर है और दूसरे फोर्स का डायरेक्शन इधर है. ना फोर्स इज अ वेक्टर क्वांटिटी. एक मान लो लेट से 3 न्यूटन का फोर्स इधर लग रहा है और लेट से 5 न्यूटन इसके जस्ट किस डायरेक्शन में लग रहा है? अपोजिट डायरेक्शन में. सो दोस टू वेक्टर्स आर गोइंग टू बी योर unlike vectors. Now we have equal vectors. Now what is equal vector? As by the name itself suggests that equal vectors or equivalent vectors are those which are having equal magnitude and also they are in same parallel support and they are in same direction. Now when I talk about its diagram, suppose this is one vector and let's say this one is another vector. Now their magnitude also has to be same and direction also has to be same. Now what is support? Support is basically an imaginary line to which both the vectors are basically going to be your parallel. So that is going to be a support. So they have a same or a parallel support and they are equal in magnitude and as well as they have the direction also same. So that is going to be your equal vectors. Now the next one is your diagram, that this is A vector, this is C vector, and this is B vector. So basically, let's say this is the support line for this three vectors. So they have equal magnitude, they are all in same direction and have the parallel support. So these are going to be your equal vectors. Now we have another term, that is collinear vectors. Now two or more vectors are said to be collinear when they are parallel, right, irrespective of magnitude and direction. That means if I say, let's say this is one vector and this is another vector, so they are parallel, right? Magnitude may differ, but their direction must be same, or they must be in opposite direction also. That is also going to be your collinear. Why? Because collinear की अगर हम बात करें तो मैग्नीट्यूड चाहे कुछ भी हो जाए, डायरेक्शन या तो पैरेलल होना चाहिए या एंटी पैरेलल होना चाहिए. मैग्नीट्यूड इज इररिस्पेक्टिव, मैग्नीट्यूड कुछ भी हो कोई फर्क नहीं पड़ता. सो दैट इज गोइंग टू बी योर collinear vector, right? So if I ask you that every equal vector is a collinear vector, yes of course. हमने जो इससे प्रीवियस देखा, so that was basically your equal vectors. तो equal vectors collinear तो हैं because they are in same direction. अब वहां पे मैग्नीट्यूड भी सेम हो गया, so they are equal, right? बट अगर मैं बोलूं क्या every collinear vector is an equal, तो उसमें प्रॉब्लम है, right? Because डायरेक्शन सेम हो भी जाए बट मैग्नीट्यूड सेम कहाँ है. So every collinear vector is not a equal vector, but every equal vector is a collinear vector, right? Now we have co-initial vector. Now what does this co-initial means? Two vectors having same starting point. That is, let's say if this is one vector and this one is another vector, and both the vectors have a same starting point, so that is going to be your co-initial vector. This is like you can see there are four vectors, A vector, B vector, C vector and D vector. All are starting from the origin. So they are starting from the origin. So their initial point is origin. So they are all co-initial vectors. Now, when we see the next one, we have coplanar vectors. Now, what is coplanar vectors? Suppose if I say this board is a plane and I am drawing, let's say these are your basically three vectors, right? So they all are in same plane. That means they are coplanar. So what is the definition? That is, three or more vectors are called coplanar if they all lie in the same plane or they are parallel to the same plane. Let's say if I talk about this stylus, so this is also going to be coplanar because it is also parallel to this plane. So you can just take this on this plane. So that's going to be a coplanar. I hope it is clear. Now we have to note this important point. Now what's an important in this? That two free vectors are always coplanar. Means अगर कोई भी दो वेक्टर हैं तो हम उन दो वेक्टर्स को कंटेन करने वाला एक प्लेन ले सकते हैं. सपोज इफ आई टॉक अबाउट दीज टू थिंग्स, सो इनको कंटेन करने वाला भी एक प्लेन तो होगा ही होगा डेफिनेटली, राइट? सो दो वेक्टर हमेशा कोप्लेनर होंगे. यू मस्ट नो दिस. नाउ द नेक्स्ट वन इज योर negative vector. Now what is negative vector? Basically a vector having the same magnitude as that of the given vector but direction is going to be just opposite. Like for example, if I have a vector as this, now let's say if this is your a vector, so negative of a vector is going to be your this. Now what's interesting in these two, that they are of same magnitude but their direction is just opposite. Fine. So that is going to be your negative of a vector. Means अगर आप किसी वेक्टर को माइनस से मल्टीप्लाई कर रहे हैं, that means you are changing its direction and magnitude will remains same, right? Now we have this as your diagram which I have explained you, that this is going to be a vector and this will be your minus of a vector. Now let's move further. So we have unit vector. Now interestingly, what is unit vector? A vector whose magnitude is going to be 1, that is unit, right? So unit vector वो वेक्टर है जिसका मैग्नीट्यूड क्या होगा, 1 यूनिट होगा. नाउ यूनिट वेक्टर को जनरली हम रिप्रेजेंट करते हैं यूजिंग द सिंबल ए कैप. नाउ फॉर इंस्टेंस अगर मैं बोलूं हमारे पास जो हमारा ए वेक्टर है, let's say it is going to be your something like 2 I cap plus 3 j cap plus of 4 k cap. Now if I ask you what is going to be its magnitude, right? So magnitude is going to be basically अंडर रूट ऑफ, अगर हम इसका मैग्नीट्यूड निकालें, सो दैट इज गोइंग टू बी ए वेक्टर का मॉड, सो दैट विल बी अंडर रूट ऑफ 2 का स्क्वायर प्लस कितना, दैट विल बी 3 स्क्वायर एंड देन वी हैव 4 स्क्वायर. सो वंस वी सिंप्लीफाई दिस फर्दर, सो 4 प्लस 9 प्लस 16, सो दैट इज गोइंग टू बी योर अंडर रूट ऑफ 29. सो यहाँ पे हमारे पास इस वेक्टर का मैग्नीट्यूड कितना है, अंडर रूट ऑफ 29. So if I ask you, is this a unit vector? Of course, it's not a unit vector because its magnitude is not 1. But once we divide this vector by this magnitude, let's say what I'm saying, that once you divide the vector by its magnitude, let's say we call that as a unit vector. So that is going to be what? 2 by root 29 I cap plus how much? 3 by root 29 j cap and plus of 4 by root 29 k cap. So when we talk about this vector, that is we have divided any vector by its magnitude. Now once I ask you, is this a unit vector? So definitely you will calculate its magnitude like as you did over here, that under root of 2 square plus 3 square plus 4 square. Similarly, in that fashion, once you calculate this, you are going to have 4 by 29, 9 by 29 and 16 by 29. So that is going to be, once you take the LCM, so that will be 29 by 29. So definitely it is going to be 1. So to calculate a unit vector, this is going to be the formula, that you have to divide a vector by its magnitude and you will get a unit vector. I hope it is clear. Now we have question based on this. Now what does the question says, that this is the vector and you have to just calculate unit vector in the direction of a vector. So if I ask you what's going to be its magnitude, so that's going to be basically your under root of 1 square plus of minus 1 square and plus of 1 square. So once you calculate this further, so this comes out as root 3. So you have to just divide it by root 3. So you'll have D as your correct option. So this is going to be the unit vector which will be in the direction of a vector. Fine. Now we have another important thing, that is angle between two vectors. So what is going to be the angle? Let's say if this is your one vector and let's say this is your another vector. Let's say this one is your A vector and this one is your B vector. So basically we have to calculate this theta, that is your angle between two vectors. So basically do remember that when you are calculating angle between two vectors, so what you have to exactly do is you have to keep two vectors as your co-initial vectors, or you can say that their tail must coincide, and the theta can be basically anything between 0 to pi. Now why 0 to pi? You have the diagram for this. Once we have taken this as A vector and this as B vector, so this is going to be basically an angle theta. Now here the theta is basically your acute, right? So that will be 0 to 90. Now when we take this, let's say this is A vector and wherever the head of the A vector is ending, from there we have taken a tail of B vector and we have taken in this direction. So you have to extend A further. So this is going to be the angle basically between A vector and B vector. Now this angle is going to be basically look like as this. So that is going to be your obtuse. So that will be from 90 to 180. So in general we can conclude that the theta is going to be between 0 to pi. So this is how we are going to calculate the angle between two vectors, right? Now we have a multiplication of a vector by a scalar. That means suppose we are given a vector and we are multiplying it by a scalar. So what going to happen? So when we see, we have one vector, that is A vector, and over here we are having a lambda, that is your scalar, right? For instance, let's say we have A vector and that is going to be equals to what? Let's say it is 2 I cap plus 3 j cap plus of 4 k cap. Now what you are going to do? You are going to multiply a lambda to it. Lambda is, it could be anything constant. So let's say if you have multiplied it by 3, so B vector, basically you are taking lambda as 3, means you are finding out it as 3 times of A vector. So what we can write it as B vector will come out as what? 6 I cap plus how much? 9 j cap plus how much? 12 k cap. So this is how we are going to multiply a scalar with a vector. Now what is interesting, that if this lambda is positive, right? So basically they are in same direction, but we can say that the magnitude of A is less and B is 3 times of the magnitude of A, right? So this is going to be a case of, we can say they are like vectors, or we can say they are collinear vectors because they are in same direction, right? If lambda is going to be negative, like if you take lambda as -3, so basically they are going to be in opposite direction, again they are collinear. So you can take this as a condition of collinearity also, that if one vector is lambda times another vector, so that is going to be basically these two vectors are going to be your collinear vectors. I hope it is clear. Now we have an important point, that is magnitude becomes lambda times the another. As I said, let's say if A vector whose magnitude we have calculated earlier also, that was under root 29, but you are multiplying it by lambda. Let's say lambda is 3, so magnitude is going to become thrice, right? So that's an important point to be noted. Now we have division of a vector by a scalar. Like earlier we have studied multiplication of vector, multiplication of a scalar by a vector. Now we are going to study division of a vector by a scalar. So when we talk about division of a vector by a scalar, so that scalar has to be basically non-zero. Non-zero means it cannot be 0, because if it becomes 0, so that is going to be your undefined, right? So what we are going to have, we are going to have m, and that m has to be basically non-zero. So basically division of a vector by a scalar by a vector is going to be basically multiplication of 1 by m, right? So again it is going to give you a condition of, as I said, that they are collinear vectors. Now in this case, if I say let's say m is 3, so हम ये बोल सकते हैं कि जो new vector which comes out as that will have 1/3 of magnitude of what we have, right? मतलब जो भी b vector का magnitude है, a का जो भी magnitude होगा that will be 1/3 of the magnitude of b, right? So that's again a condition of collinear vector. Now we have question based on this. Now what does the question says, that suppose there is a physical quantity, let's say a mass which is of 3 kg and is multiplied by a vector a such that force is equals to mass into acceleration. So we have force equals to mass into acceleration, and we have to find the magnitude and the direction of f, right? So if acceleration is 3 meters per second square towards east, now you must be knowing that this is going to be your east, right? This one will be your north, this is going to be your west, and this one will be your south. So if I ask you that you are given the mass, you are given an acceleration. Now again acceleration is vector quantity, and if acceleration is a vector and this m is a scalar, so as I said, multiplication of scalar by a vector is going to give you a vector. So if the acceleration is along 3 meters per second square towards the east, so force is also going to be towards the east, and that is going to be how much? 3 into 3, so that will be how much? So force will be acting towards the east is going to be a 9 newtons. So that will be the direction of force for the first case. So I can say over here that acceleration and force both are in same direction, right? So they are basically a collinear, but magnitude may differ, right? Actually it differs because acceleration's magnitude was 3 and the force was 9 Newton, right? Now once we talk about the next one is acceleration minus 4 meter per second square northwards. Now if I ask you minus 4 towards the north, so that is if you take a negative of vector, so that will be 4 towards south, right? Or we can say if you want to take it as that it is going to be basically towards the north only, if you want to take it as towards the north, so we can take the sign as well. So अगर minus 4 is towards the north means acceleration नहीं हो रहा है, negative acceleration indicates that वहाँ पे क्या हो रहा है, retardation हो रहा है. So if I ask you to calculate the magnitude of force, so acceleration is minus 4 and mass is 3. So magnitude of force is going to be what? 12 Newton. Now as they are asking only the magnitude, so it's not necessary to indicate the direction, but you can say that 12 Newton force, and that will be retarding force towards the north. Is that clear? Now we have another important thing related to this, that is going to be your laws of addition and subtraction of vectors. Like we want to study that how two vectors can be added or subtracted. For that we have certain laws. So let us discuss it one by one. Now for that we have graphical method and also we have mathematical method. So first we're going to study graphical method. So suppose in this first we have triangle rule of vector addition, means we want to add two vectors using triangle law, right? So there are certain steps for adding two vectors representing same physical quantity by a triangle law. And what are those steps? So we have to keep vectors such that tail of one vector coincides with the head of another. For instance, let's say this is your one vector whose tail is over here and head is over here. Let's say this is your A vector, right? And another vector we have to take such a way that the tail of another vector coincides with the head of the previous vector, right? So this is going to be your B vector. So basically you will have a resultant joining tail to tail and head to head. So that is going to be a C vector, or you can take it as the resultant vector. So let's say that will be your R vector. So this is basically your triangle law. So the first point was clear, join. Second point was join tail of first to head of the other by a line with an arrow at the head of the second. Means you have to just take the resultant as tail is joined with tail and head is joined with head. So that is going to be a resultant vector, right? And the new vector is going to be the sum of two vectors and also count the resultant vectors. So that's the diagram. And I said this is A vector, this is B vector, and this is going to be your C vector. So basically we have R vector or C vector that will be equals to A vector plus B vector. So this is basically your triangle law of vector addition. Now that's a graphical method. Now based on this we have a question. Now what does the question say is that a body moves 4 meters south and the 5 meter in the direction of 37 degree east of north. We have to find the resultant displacement. So basically we'll take a body that moves 4 meters south. So 4 meters south means in this direction. Now that's basically body is moving towards the south. That is going to be your how much? 4 meter. And the 5 meter in the direction 37 degree east of north. Now if I ask you east of north, so this is going to be basically east and this is going to be your basically north. So if I say east of north means you have to take an angle 37 degree. East of north means you have to take an angle with north. Now this is given to you as 37 degree, right? And body is moving in this way, right? So that is earlier it moves towards 4 meter and then 5 meter in the direction of 37 degree east of north. So that is in this direction. So I can say that this is going to be basically your 5 meter, right? And we have to find the resultant displacement. So let's say this is initial position, right? Now earlier it has gone towards this. Now that is basically your 37 degree and then 5 meters towards this point. So if I ask you, this is initial and this is final. So displacement is going to be basically final minus initial. So this will be your basically displacement. So now let's take this as X. Now you have this as your 37 degree. Now you can even apply the Pythagoras theorem to get the value of X, and the value of X comes out as your 3. Now how does 3 comes out as? Because 5 square is 25. You know the Pythagoras theorem. So hypotenuse square minus this is going to be base, that is 4 square, that is 16. So 25 minus 16 is going to be your 9 and under root of 9 will give you this as 3. So this is going to be basically your 3 meter, right? So the resultant displacement is going to be your 3. I hope you understood it. Now we have polygon law of addition. Now what is basically your polygon law? Now polygon law is basically, let's say you are adding more than two vectors. So we are going to use polygon law. Now this is again an extension of triangle law of addition. We'll understand it. So we have a arrangement such a way that next vector lies on the head of the former. So we'll see to it that how does it looks like. Suppose this is your A vector. Now this is going to be B. So this will be the resultant as per the triangle law, that will be A plus B, right? Now again we have C vector in this direction, right? So again we apply a triangle law. So this is going to be our A vector plus B vector plus C vector. So every time what you are going to see, that resultant vectors has the same as your head, and the initial point for the C vector is going to be the same. Now means what I mean to say, that this is A plus B and this is C. So head of A plus B coincides with the upcoming vector, that is your C vector, and this will be your basically A vector plus B vector plus C vector. And then again you have A vector plus B vector plus C vector, then upcoming vector is D vector that coincides with the head of the resultant, and in this way it's going to continue. So that's your polygon law, right? So the final edge of the polygon, if I say, so that is going to be the resultant. Let's say this is P. So P vector is going to be vector addition of all those edges, that is A plus B plus C plus D. So that's going to be your polygon law. I hope you understood it. Thank you.